we have tan P, if tan is y over x, and it's in quadrant 1. So I know y is 5, I know x is 12. How I find r, and the great thing is if you didn't draw these ones, you'd luck out, because r is always positive, right? So you would have ended up lucking out when it's tans. So you often don't use tans, they'll use cosine signs, so you have to draw them properly. But r squared equals 12 squared plus 5 squared. R squared equals 144 plus 25. So r squared equals 169. And when we square root that, we get plus or minus. However, r is always positive, so it's 13. Okay? Then I do this one. Now it says tan has to be between pi over 2 and 3 pi over 2, which gives me actually 2 quadrants. We agree? But tan has to be positive, and the only quadrant out of those two where tan is positive is quadrant 3. Now quadrant 3 throws you off if you don't draw it. Pay attention, please. If you don't draw it, it's going to throw you off because it looks like it looks like these y's and x's are actually positive, but they're not. It's y over x, correct? If they were both negative, the negative sign goes away, correct? So they'll throw it into quadrant 3 all the time, because when you go to draw it, you'll be like, oh, y has to be negative 4. And x has to be negative 3. What's a negative divided by a negative? A positive. So there's no remnants of the negatives there anymore, but they are there because you drew them in that quadrant. That's why drawing these quadrants are so important. Drawing the triangles are so important. When you solve for r, you will get 5. Okay? Now we need to go to our formula. Sine p minus q is sine p. This is my a. This is my b. I need to use the minus formula, correct? So it's sine p cos q minus cos q minus cos p sine q. So sine of p, go to p, sine is y over r, so it's 5 over 13. Replace. Toss the sine p out. Cos q. Q, cos, x over r. So it's negative 3 over 5. Minus cos p, go to my p, x over r, 12 over 13. Sine q, go to my q, y over r, negative 4 over 5. So we're going to get negative 15 over 65 plus 48 over 65, which gets you 33 over 65. Flip over to the next page, try the question at the top. I will come back to this one. I just want everyone to be able to write this one down, because I remember they're printed really weird. So write this one down properly. It says determine the exact values of cos theta plus pi over 6. So you can do that one separately, knowing that tan is 4 over 3 and it's in quadrant 3. And then you can do the question again with sine theta. So we're going to do one question with cos theta plus pi over 6. And then you're going to do the next one with sine theta plus pi over 6. Draw the triangle. Tan 4 over 3 in quadrant 3. Make sure it's written down correctly, because it wasn't, probably, I would assume.
I don't think I can do this.
So the first thing I want to do, make sure you're following along. So this is A, this is B, okay? So we go to our formula sheet of cos A plus B. So we're going to go cos A, cos B, A, sorry, is theta, cos theta, cos B, which is pi over 6, minus sine theta, sine pi over 6. Problem is, I have the pi over 6's off my unit circle. Problem is, I don't have the sines and tans, but I can get that from the triangle, right? Have I drawn a triangle? No, so I need to do that first. So it says tan is 4 over 3, and it's in quadrant, shocking, 3. It's where it often falls if it's a tan, because they're testing if you can make them positive or negatives properly, right? So if we draw it here, this is triangle theta, because it's tan theta. Tan is y over x. So my y is actually what? Negative 4, because I drew the triangle, and I know it's negative 4, and my x is negative 3, and the negative divided by negative is a positive, and there's no remnants of it, right? But they're negative because you draw the triangle. Okay? Now r, we're going to go and solve it out, and we get 5. It's the exact same triangle as last time, right? Okay. So what is cos of the theta triangle? Cos of the theta triangle is x over r. So it's negative 3 over 5. Minus, what's sine of the theta triangle? Sine is y over r. Negative 4 over 5. Cos of pi 6 is root 3 over 2. Sine at pi over 6 is 1/2. So I multiply negative 3 times root 3 is negative 3 root 3 over 10 minus negative 4 times 1 is negative 4 times 1 is plus 4 over 10. So now I get negative 3 root 3 plus 4 over 10. No, stop. Box that baby. Because unless the number can come out here, here, and here, we're not taking it out. And it can't.
So stupid.
We're done. Yeah?
Everyone started talking.
Make sense?
Okay.
Yeah.
I was gonna say you can't like combine like the 2 plus 2, but
Right. Yeah. Okay, let's look at the sine one. So this is my A, this is my B. So I'm going to get sine theta cos pi over 6, because it's cos B, plus cos theta sine pi over 6. Where does sine theta come from? It's the theta triangle. Sine is y over r, so it's negative 4 over 5. Cos pi over 6? Positive root 3 over 2. Pi over 6 in quadrant 1.
Oh.
Plus cos of theta is x over r, so it's negative 3 over 5. Sine pi over 6 is 1/2. So I'm going to get negative 4 times root 3 is negative 4 root 3 over 10 plus negative 3 over 10,
Because 5 times 2.
which equals negative 4 root 3 minus 3 all over 10.
You're doing great.
Number 20 from your homework should be easy to do now, because it is actually just 2 triangles, an A triangle and a B triangle.
I like triangles.
I want you to try to simplify this. Separate sheet of paper. Grab a separate sheet of paper. I'm not moving on today. I don't even care. So, separate sheet of paper. Separate sheet
I
of
don't know
paper.
how much you have planned, but it's like almost 3 already.
Simplify. It's on just a separate sheet of paper. Simplify. Okay. Cos pi plus x plus cos pi minus x. Now, what do I have to spot immediately? Equations. There's going to be two equations I'm going to pull off of my formula sheet with different a's and b's. Now, in the past, when you had an a or a theta or an x or a p or a q, I gave you a triangle. We agree? And then you could substitute in. Yes? This is easier. I'm not giving you a triangle. I'm just asking you to simplify. So the cos x's will stay cos x, and the sine x's will stay sine x. Nothing gets filled into them. We're just simplifying. It's like a part of a proof, almost. Nothing to fill in. So, plug that into the formula. It should be long like this. Then the plus sign. Then plug this into a formula. It should be like this. Try it out. At least try and fill in the blue and the red. So this is A. Ooh, that's aggressively thick. This is B. So we're going to have cos A, which is pi. Cos B, which is x. Stay in that way unless I have a triangle. Did I give you a triangle? No. Cos x, stay in. Okay? Then I have sine of A, which is pi, sine of B, which is x. No triangle. That baby's staying. All right. Moving on. This is A. This is B. So this is going to be cos A, which is pi, cos B, which is x, plus sine, because that's what the formula has in it, sine A, which is pi, sine B, which is x. Staying, 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 staying. Don't have any triangles, right? If I had an x triangle, could I plug stuff in there? Yeah. Do I have an x triangle? Nah, not happening. Okay? However, when I have pi's, 180s, pi over 3's, 60s, 30s, those are all questions that I can get answers off from my formula sheet. And by formula sheet, I mean unit circle. All right. So, what is cos pi? Negative 1. So I'm going to use a green marker so you can see. This just becomes negative 1. The whole thing, cos pi. Shunk. Negative 1. Shunk. In for it. With the noise. Okay. Sine of pi. What is sine of pi? 0. Sine pi out. 0 in. 0 times anything. Bye-bye. See ya. Gonzo, Alfonso, Riviera. One after is fine. All right. Cos of pi. Once again. Yeah. But that's not where I remember him from because I'm old.
It's so random that you said it, you know.
Yeah, it's true. Cos of pi. Negative 1. Shunk. Throw it behind my head. Replace. Replace. Okay. Sine of pi. Oh, let me face. 0. Which means this is 0. Which means that is 0. Which means get out of my life. Okay. So now we have negative 1 cos x. Okay. Looking better. Go away. Don't like you. Then we have negative 1 cos x. No. And then we have get out of my life. Now, if I have negative cos x minus cos x, I actually have how many cos x's? Negative 2 cos x. Simplified. That was awesome. Yeah, that's what I thought. Good, great. Good times.
That's fun.
Not so bad. Right? Okay. So, the homework. The only thing, don't put anything away. We're gonna do next. We're gonna practice stuff. I see paper going away.
I'm moving to my homework.
No. Nope. Yes. Yeah. I'm going to put it on this board because you're going to put it on later. You're not going to go to your homework book right now. No, you're not. But page 307, 11C is the only thing I'm adding. Page 307, numbers 11, and just C. I'm adding it. I am.
That's it.
Nice.
So don't go there yet. All right. So,
I should do
yeah, you should before it drops out of your head. Okay. Because it's reals. It's reals. Did I sign 19 yesterday? I can't even remember.
No.
No, it was like 60.
Okay.
tell you what it was.
It was like 60.
You know what?
Eight.
Revamped.
28.
Okay, 11C and 19. Go to your homework and go do it right now.
Really?
Before it falls out of your head. Go, right now. I know, I backtracked. I'm going back on it. Do it. Work it. Be it. You are it. So 20 from yesterday, if you did finish it, I'm not sure how, because it was off of the stuff that we did today that people don't remember. I don't know if your brain just dropped it overnight. What else? Go back.
Well,
Yeah.
it took me like 15 minutes to figure it out.